Okay, our previous topic was wave only. Okay, now we continue with sound wave. Okay, overview of the topic. Sound waves, speed of sound waves, amplitude and intensity of sound waves, the Doppler effect and echolocation. So the learning outcome for today. At the end of this topic, you should be able to describe sound wave, calculate the speed, amplitude and intensity of sound wave, describe the Doppler effect and describe echolocation. Okay. So first, okay, what do you know about sound wave? Anyone? Longitudinal, okay. Very technical. Okay. So what is the difference between sound and hearing? Anyone know? Hearing allows one to identify and recognize objects in the world based on the sound they produce. And hearing makes communication using sound possible. So sound is derived from objects that vibrate, producing pressure variation in sound transmitting medium such as air. So got different, right? Between sound and hearing. No one answer. Only Lim Wei Huan. Ha. Okay. Before we go deep into the topic, okay, let us look at the theories. So what is the difference between hearing and sound? Hearing allows one to identify and recognize objects in the world based on the sound they produce. So for example, you sit in the living room, okay? Suddenly you hear sound from swimming pool area, okay? Where people are making noise at the swimming pool area. Okay, maybe they are playing with the kids and so on. So you hear the sound. So sound and hearing is different. Okay, so what is sound and hearing? Unlike the sense of smell or taste, which rely on chemical interaction, hearing is a mechanical process in which the ear converts sound wave entering the ear into electrical signals the brain can understand. Okay, let's say you hear someone playing piano. So your brain directly spontaneous already know, oh, this is piano sound. If you hear other thing like horn from the car, okay, or horn from the lorry, So lorry and car also have different sound. So from there you can process in your brain. Okay. Okay, next. What are the three basic components of sound? Three components are needed for sound to be heard. Number one is the source, where the sound is made. Okay, is it made in the kitchen? Okay, is it made in one of the room? Okay, so source is important. Okay, in any question later, they will mention the source is from siren of ambulance, siren of hospital, siren of police car. Okay, so the source will be mentioned. Next is the medium. A medium for the sound to travel through. So travel through where? Through the air. Okay, through the wall. Okay, and a receiver, something to detect the sound. So receiver, for example, people have the ear, so ear is the receiver. Okay, so receiver must detect the sound. For example, if you are not using receiver, you will use the sensor. Okay, sensor also must have receiver. Okay, for example, if any sound detected, then something will happen. So receiver is receiving the information from sensor. Okay. What happens to your eardrum when sound gets louder? When this high amplitude vibration impinge upon the eardrum, they produce a very forceful displacement of the eardrum from its rest position. This high intensity sound wave causes a large vibration of the ear and subsequently a large and forceful vibration of the bones of the middle ear. Okay, next is what frequency can human hear by age? Different age have different frequency. Okay, for example, people under 50 should be able to hear the 12,000 hertz. Okay, like you and me. People under 40, the 15,000 hertz. So you don't fall under the 50, right? You fall under the, okay, under the, which one? Under 30 ah? Or under 24, 17,000. Different age have different hertz. Okay, different frequency that can be received. That is why certain people, when they get older, they tend to make the TV louder. Okay, for you, it is too loud already, the sound from the TV. But for them, it is still normal. Okay, so as you grow older, don't be angry to those people. Sometimes when you talk to the old people, they also cannot really hear you, you need to use hearing aid. Also can. So don't be rude to them. You need to talk louder. Some people don't know. So they said, why are you talking so loud with them? Because actually they cannot hear. So you are trying to make them hear what you say. Okay. Next is, how is sound transmitted and heard? Okay. How they are transmitted? Sound wave enters the ears and travel down the canal of the end, at the end of which is a thin, tightly stretched membrane called eardrum. As the sound wave strikes the eardrum, it vibrates, and the vibration reaches the inner ear, which sends signals to the brain. Brain interpret the signals and we hear the sound. Okay. Next, what are the four principles of sound? Since sound is a wave, it has all the properties attributed to any wave. And these attributes are the four elements that define any and all sound. So this we have learned in our previous topic. They are frequency, amplitude, waveform, and duration. So these are the four things. Okay, four principles of sound. Okay, I hope you still remember what is frequency, amplitude, waveform, and duration. Duration, we also call it T or period. Okay. Okay, this one okay, so the main component of sound is frequency and wavelength. So if you have a waveform like this, half of the waveform from 0 go to the maximum, we call it amplitude. Okay, and then from 0 go to 1 cycle is the period or T. From the T, we can find the F. F equal to 1 per T. Okay, so this we have learned in the topic previously. So what is the sound of wave called? In physics, sound is a vibration that propagates an acoustic wave through a transmission medium such as a gas, liquid, or solid. In human physiology, sound is the reception of such wave and their perception by the brain. Sound waves below 20 Hz are known as infrasound. What are the two types of sound wave? So the two types are two types of wave, transverse and longitudinal. Okay, already learned in the previous chapter also. Transverse and longitudinal. Okay, next. Can sound travel through a vacuum? Why or why not? Sound does not travel at all in space. The vacuum of outer space has essentially zero air. Because sound is just vibrating air, space has no air to vibrate and therefore no sound. So if you are asked, can the sound travel through vacuum area? Cannot. The answer is cannot. Okay. Sound waves are traveling vibration of particles in media such as air, water, or metal. Okay. So air you cannot see. You cannot see, but don't say The sound cannot travel through air. Okay, air you cannot see, but it is there. And then through water. Through water, if you shout in the swimming pool, if you shout in the swimming pool, can anyone hear you or not? It's difficult to hear, but still can hear. Okay. And then metal. Okay, metal also can hear through metal the sound. So what happened? What happened when a sound wave enter vacuum? They causes particles to vibrate parallel to the direction of wave travel. Sound cannot travel through a vacuum because there are no particles to carry the vibration. Okay, so this is the statement that must support if you are asked why the sound wave cannot travel through vacuum. So your answer should be sound cannot travel through vacuum because there are no particles to carry the vibration. Okay. So now we continue the lecture notes. Sound waves are caused by vibrating string, membrane or other object which is in turn transmit the vibration to the air. Okay, for example, human at the park, okay, at the park, they can talk and people can hear in the park because in the park have air. Sound waves are longitudinal. They can represented by either variation in air pressure, gauge pressure, or by displacement of an air element. Audible frequency range of human is between 20 Hz to 20 kHz. So the range is big. Okay, the range is big from baby until oldies. Okay, so just now I have mentioned for certain age, the sound is different frequency. The loudspeaker produce pressure fluctuation that travel to the air in all direction. Okay. Variation in air pressure and corresponding waveform. So from the speaker, it travels to the ears or eardrum. Okay. Then this is the waveform which is produced from this sound wave. Okay, so three characteristics are used to describe sound wave. First is wavelength. Okay, wavelength from 0 go back to another 0, become one cycle. So wavelength must count from 0 go back to 0, or from peak go back to another peak. Okay, not from this peak go to this peak, cannot. Positive peak go to positive peak back. Okay, or this is the distance from the crest of one wave to the crest of the next. Next is frequency. Frequency is the number of waves that passes a point in each second. Frequency is at the bottom here. So to count the frequency, we already know the formula is F equal to 1 over T. Okay, where T is equal to period of one cycle. Okay, I put in the chat also. Next is amplitude. Amplitude is measured of amount of energy in a sound wave. Okay, so amplitude is from peak to peak. In some region of air, the molecules are bunched together. Compression and pressure is higher. Okay. In other region, the molecules are spread out and pressure is lower. So if you cannot imagine about this pressure, you imagine you go to the higher hill. Okay. For example, you go to Genting Highland. Anyone have been? Anyone have been to Genting Highland? Muhammad Saad already been there. So you have play with the outdoor games in there or shopping. Huh? Have the factory outlet there? Shopping also? Okay. So when you go into Genting Highland, what happened to your ears? If still cannot imagine, you go into the flight. Faster. Hear noise. Oh my God, hear noise. High pressure. High pressure when you go higher to mountains or hill. Or you go into feels like block. Your ears like block, right? So what normally old people ask us to do? To settle the block. Samuel, what the other people, no other people lah. What your parents ask you to do? Swallow saliva. Or close your nose, right? Close your nose and mouth. Then blow. Also can. To settle the pressure at your ears. Okay, so you become painful a bit lah at the ears, right? Okay, so this happen when you go to higher area like taking flights. Flight about to okay, flight about to go out or about to go down. Right, got different, something different will happen to your ears if you still remember. Nowadays, long time we never go with the flight anymore since COVID. So that is why some people, they are scared to take the flight because they will have a painful at their ears. Okay, but not happen to everybody. Some they know how to settle. Okay, air turbulence. Also. Okay, so this is the mention here. In some region of air, molecules are bunched together and pressure is higher. Later people ask you where we can see the pressure is higher and effect to us. So you must know where to imagine. Okay, the middle of compression correspond to a pressure maximum, while the middle of rarefaction correspond to a pressure minimum. Okay. Anyone have gone to the using the cable car to go to Genting Highland? Or you drive through, go up? Hmm? Drive up ah. Oh, rajin you. Very difficult to drive up also, right? Got many cars. And then not safe. Okay, so most people will park at the cable car parking and take the cable car to go up. Okay. So when you are in the cable car, do you hear any sound? Can hear the next door cable car? Not sure. Okay. No reaction also. Not sure. Okay. In cable car, you can breathe, right? If can breathe, can hear sound from outside. If cannot breathe, then no air. The speed of sound in different material can be determined as follow. So in fluid, V equal to square root of B per rho, where rho is the density and B is the bulk modulus. So this is the velocity of the sound wave, V. And then in thin solid rods, V equal to Y per rho, square root, where Y is the Young modulus of the solid and rho is the density. So materials that have high restoring force, stiffer, will have a higher sound speed. Materials that are denser will have a lower sound speed. So these two formula you have seen before in other chapter. Okay. In ideal gases, V equal to VO square root T per TO. Who's that? Oh, Ng Ziyi. Okay, where VO is the speed of sound at absolute temperature. Absolute temperature is measured in Kelvin. T equal to TC plus 273.15. And V is the speed of some other temperature. So why they mention this? Because if the question given to you in degrees Celsius, you need to plus with the 273.15 to convert it to Kelvin, then only you can put into this formula. Okay. So in the last chapter also, we will be using this for the temperature and heat chapter. Okay. This is the second last topic or second last chapter for this subject. Okay, example. The speed of sound in air at temperature 0 degrees Celsius is 331 meter per second. Therefore, the speed of sound in air at room temperature 20 degrees Celsius is how much? They ask. Okay. So this T Okay, T, you must add the 20 TC, original temperature TC, 20 plus with 273, no need the point also sometimes. This will be given whether you use 273 or 273.15. Okay, will be given the standard value that you must use during exam. So here use 273 only. So 273 plus 20 get 293. Okay. So formula is V equal to VO square root of T per TO. So VO is the speed of sound 331. T is 0 plus, not 0, 20 plus the 273 divide by TO. TO is 273. Therefore, the answer is 343 meter per second. Okay, understand the calculation? Simple, right? Just put in the formula only. Okay, next we do another example. A copper alloy has a Young modulus of 1.1 times 10 to the power of 11 Pascal and a density of 8.92 times 10 to the power of 3 kilogram per meter cube. What is the speed of sound in a tin rod made of this alloy? Okay, so first we need to know what type of, here mentioned copper alloy. Why we need to know the type? Because if not given in the question the density value, you must find the density value from a table. So from the table have aluminium, copper and other metals. So you must be alert which alloy they are using. Okay, so here copper, the rho or density is 8.92. Okay. So speed of sound in tin rod is square root of Y per rho. So Y is the Young modulus, substitute here. Rho is 8.92. To be more specific or more detailed in the calculation, substitute 8.92. After the final result only, you leave it in 2 decimal point. Okay? Because sometimes during calculation, you shortcut already. Later, the answer will be a bit different. If a bit still can accept, can get full mark. But a bit far, maybe second marker will reduce. Okay, so be careful when doing calculation. Next is the intensity. Intensity is proportional to the amplitude squared. Applies to all wave. So previous wave also we have learned intensity. What wave that we learned before? I have used torchlight as the example, right? Remember or not? I used torchlight as the example. For example, you want to find things under your bed, you use torchlight. So torchlight also have several level of intensity that you can turn the torchlight. So certain intensity will make it sharper, the light, or brighter. Or you want it to have a bigger area lightings. Then you adjust the, what you call that, torchlight. So for sound also have intensity. So intensity for sound is proportional to the PO, to the power of 2, where PO is the pressure amplitude and I or intensity also is proportional to the SO. SO to the power of 2 is the displacement amplitude. Okay. So from there you get a formula PO equal to omega V rho SO. Okay. When to use this? When they ask you, for example, calculate the displacement amplitude. Displacement amplitude they ask you to calculate, but you don't have the T. Okay, for example, this one. Not this one, this one. This one you can calculate the velocity or the speed of sound if they give you the temperature. Okay. Here don't have the density also. Okay. This one you can calculate the speed of sound when they give you density. Okay. Depend on information what they give. That's why there are many formula. Okay. Then one more. If they ask you to calculate the displacement of amplitude SO, SO bring left side. Okay, SO or this whole thing, SO equal to PO divided by omega V rho. Okay, so not all formula can be used. Depend on what information is given. Okay. Loudness is often in terms of intensity. Where you can hear loudness? Pasar malam. Pasar malam, you know, night market. You can hear a lot of loud people not shouting. They are promoting their things. Okay? They are promoting their things. So they need to have a loud sound from their voice. Because of what? Because pasar malam or night market, there are a lot of people walking. So they must overcome these people sound. People also talking. Okay, people also laughing with friends. So people making noise. So the night market people, they also need to overcome the sound from people and also overcome the sound from other shop. Later other shop also sell what? What you normally buy in night market? Who I should ask? Sutage? Buy food? Yes. What type of food, Samuel? In night market? Snacks? Okay. You buy fried chicken, you buy char kway teow, right? Drinks? Okay. You buy tofu pho, okay? So from all these food and drinks, which one is producing highest sound? Fruits. Very good. Fruits normally is cheaper in night market because they sell in bulks. Okay. Compared to you go to Jaya Grocer. Some people got speaker and mic when advertising. Yes. They use the big speaker. Okay. For example, everything RM1, everything RM1, but in Malay lah. Okay, if in Malaysia. Okay, any items RM1. Right? Or RM5. Any items RM5. So depend you choose the expensive one or cheap one. Everything is RM5. So choose the expensive one lah. But actually you must choose the suitable one that you want to use. Sometimes blindly buy also. Right? Don't want to use also want to buy. Okay, noise pollution. This noise pollution always happen in APU, right? Do you realize? Where is it? Is it in classes? Construction? Okay lah. Construction can. Other than that is classroom next to you. For example, you will be having class test or quiz in your classroom. Then next room, other classes not yet started, so the student very noisy. So this will distract you in doing your quiz or class test, right? So you must be careful in any time. Other than that, the most crucial one for me lah. For most crucial one is in the elevator, in the lift. Okay, in the lift because student keep on talking, lift already cramped. Many people in the lift small. Some more student talk because maybe they don't know I'm a lecturer there. Or they don't care. Okay, so try to respect others in the elevator especially. You might not know because maybe some of them they wear the headphone, right? From the phone. Nowadays is wireless. You cannot see also the headphone. So maybe they are talking very loud, but their friend is using the headphone, cannot hear also. Okay. And then the sound is at a closed area. Okay, elevator. So try to noise cancellation. Also can. But scared to use lah. Later if you want to what you call that? If you are at the roadside, you want to move to another road, then if you use noise cancellation, it's a bit dangerous, right? I know you can use your eyes lah to see or switch off during that time. Okay lah. That is good. Okay. So nowadays, if lecturer requires to do the online class, they must have a soundproof room. Soundproof, you know. Soundproof room for what? For example, your neighbor is noisy or your children is shouting here, shouting there with cousins. So you cannot control, right? So you must enter a room which is soundproof. So that you will concentrate, a student hearing also concentrate. Okay. So there are many ways to make this soundproof room also. Okay. Blocking outside sound. Yeah. So that is why you learn this topic actually. Where you want to apply it. Okay. So loudness is often measured in terms of intensity rather than amplitude. Intensity of sound wave. I equal to PO per 2 rho V. Okay, where rho is mass density of medium, V is speed of sound in that medium, and omega is angular frequency. Now we look at this example. The song of the brown creeper is very high in frequency. Okay, about the bird. Anyone have bird at home? No. Maybe mostly people will take a cat or dog, right? Which you can hold. Because bird you can hold, right? You can see only. Birds are annoying, but the one that can talk, Sutage, expensive, right? The one that can talk. Burung kakak tua. Parrots. Yeah. So, this brown creeper is very high in frequency, as high as 8 kilohertz. You are out in the woods and hear the song. Hear song still okay, right? If you in the wood, you hear ghost, how? What you will do? Huh? Run away or shouting also? Anyone have seen ghost before? No. Some people have the ability to see ghosts, or even some can communicate. Okay, for us, we are scared. But not to the extent too scared lah. Okay. I have friends who are scared to go into staying in hotels. Because she will imagine there's a ghost in the tub. Whatsoever, she imagine everything. To go into the boat also she's scared because she will be imagining the ghost will come out from the sea. Too much imagination, too many movie maybe. Okay, not to that extent Because during university time, I used to go for camping also. So still okay to go to the wood. Okay, how about you? You like to go camping or not? Oh, UUM. Who in UUM, Lim? Luasa. Some people don't like to go for camping. They only like to go for shopping. Okay, some people don't enjoy the extreme. Not the extreme for camping also, right? Once in a while, gathering with friend, right? Go to camping. Okay? No need to go to the wood also can. You can go to the Port Dickson next to the sea, at the near to the beach. Oh, Gunung Tahan. Gunung never go lah. At the bottom of gunung, at the bottom of the mountain, got go. Okay? So go to the what you call that? Taman Negara. That one got jungle trekking, many things Okay, or nowadays they encourage you to go to Langkawi, the island. Then you can go to the Telaga Tujuh. Also can climb next to the river. Sometimes you need all this to release your stress. Okay. Since we have COVID before this, now still have, but not that much, right? So take some time with your family or friends to go for outing. Because it will make you, what you say, really stress, become calm. Okay, look at the sea, look at the lake. This will really stress a lot. Okay, or you can go for what you call that, wall climbing. Wall climbing in Extreme Park, Shah Alam also have, Putrajaya also have. From APU near to go to Putrajaya. Okay, so bring your friend, go together. Okay, provided 2 dose already taken. Okay, advertisement finish. You are out in the woods and hear the song. If the intensity of the song at your position is 1.4 times 10 to the power of -8 and the frequency is 6 kilohertz, what are the pressure and displacement amplitude? Okay, so pressure is P, displacement amplitude is just now SO, for example. Later we see. Assume temperature is 20 degrees Celsius and the speed of sound in air is 20 degrees Celsius. Is 343 meter per second. And the raw air is 1.2 kilogram per meter cube. So intensity and pressure related to this formula. I equal to PO per 2 rho V. Okay, so PO equal to, this one got square, PO to the power of 2. So when you don't want to the power of 2, this whole thing you need to square root. Okay. Okay, so then substitute the value. I is 1.4 times 10 negative 8, the I intensity. Next, the rho, 1.2 kilogram per meter square, meter cube. The unit no need to put in the calculation. Later you confuse. Okay. And then the V is 343. So after calculation, you get 3.4 times 10 to the power of -3. Okay. Next is the pressure and displacement amplitude are related to PO equal to omega rho V. Omega V rho SO. Therefore, use the formula. Intensity is equal to this. Then substitute all to get SO. SO is the displacement amplitude. So even though the question is simple, but if you wrongly pick the formula to use, then it will be problem for you. Previously, I have mentioned for the final exam, any formula taken directly from the formula sheet will not have mark. This one, for example, this one in the formula. Okay. Then you manipulate become this. This have 1 mark. If directly this don't have. Okay, so here 1 mark. Here you think how much? How many marks for this? 2. 2, right? Substitution 2. Final answer 1. So 1 3, 4. 1, 2, 3, 4. Total for PO only 4 marks. Suitable. Okay. Next, to find the displacement amplitude, what is the good marks? This one, no. This one, this one is in the formula sheet. Okay, so after you manipulate, you get this one. This one can give 1 mark. This one quite complicated compared to this. So this one can be 3 marks. Because after this got another one, then only this. This one 1 mark. Okay. Okay. Okay, before we go into the Doppler effect, wait ah. Okay, we break for 10 minutes before doing some other exercise. Dah, dah, dah. Okay, everyone already in. Okay, we continue now. So the next topic is called the Doppler effect. Okay, what is Doppler effect? So when a moving object emits a sound, the wave crest appears bunched up in front of the object and appear to be more spread out behind the object. This change in wave crest spacing is heard as a change in frequency. Result will be similar when the observer is in motion and the sound source is stationary. And also when both the sound source and observer are in motion. So in this picture, you can see that the boat is moving. Okay, the boat is moving and the boat have a siren. So the sound will be heard by someone. So when both the sound source and observer are in motion, the result is the same. Okay. So now we look at the video. I'll share with audio. Okay. Application of Doppler effect.
Doppler effect. The illustration shown here will help you understand the Doppler effect. I'm sure you would have heard an ambulance speeding past you. That is, the pitch of the siren increases as the ambulance approaches you, and the pitch decreases when the ambulance moves away from you. There is a similar apparent change in the pitch of the sound heard when the source of sound is at rest and the listener moves towards or away from the source. The change in pitch is due to a shift in the frequency of the sound waves. Based on these observations, an Australian physicist and mathematician J.C. Doppler proposed the Doppler effect in 1842. According to the Doppler effect, the apparent change in wavelength of sound or light is due to the motion of the source, observer, or both. Doppler effect is observed in light also. Suppose a star recedes from Earth, then the frequency of the light emitted by the star decreases or wavelength increases. Thus, the spectral lines are shifted towards the red end of the spectrum. This is called redshift. Similarly, when a star moves towards the Earth, the spectral lines shift towards the blue end of the spectrum. Applications of Doppler effect. To find the velocity of a speeding car. Let us see how a traffic police catches speeding motorists. Short waves emitted from an observation center are directed towards the speeding vehicle. These waves are reflected by the car to the observation center. By calculating the shift in the wavelength, the velocity of the speeding car can be determined. To determine the depth of oceans, we can apply the Doppler's effect for estimating the depth of the oceans. For this, we make use of sonar. A transmitter from a ship transmits sound waves towards the ocean floor. These waves are then reflected by the ocean floor and are received by the receiver. Note the time taken by the waves to come back to the source. Now we can estimate the depth of the ocean by using the formula d is equal to v into t by 2, where v is the velocity of sound waves and t is the time taken. To calculate the speed of astronomical bodies, the Doppler effect of light can be used to measure the speed of stars and galaxies. The spectrum of light coming from the planets and stars are photographed over a long period. By observing the Doppler shift, one can conclude whether they are moving towards or away from the Earth. To study Saturn's rings, concentric rings surround the planet Saturn. These rings reflect light and are not self-luminous. The Doppler shift of light reveals that the rings are not continuous, but they consist of many particles.
Grammarly Business is an AI-powered writing assistant, enabling teams around the world to...
Okay. So what you understand from the Doppler effect? Anyone? From the ambulance just now? No answer also. Signals. So as the as the ambulance go far, you will hear the sound you will hear slower, right? Okay, compare when the ambulance is there near you. That is logic, but sometimes they will ask in terms of sentence. Okay. So moving sources. Just now, this Doppler effect is used. Okay. Wait Use in moving sources. Okay, so sources can be from sources equal to ambulance or sirens. Okay. So this topic is about sound only. We don't care about the lighting and all. That one is another chapter previously. This chapter only observe the sound. Okay, sound wave. So for the moving source, okay, we have this formula for Doppler effect. So FO is the observed frequency. How to calculate observed frequency is equal to 1 per 1 minus Vs per V. Vs is source velocity and V is the speed of sound. So to calculate the observed frequency, you must know these two information to put into the formula. Next is to multiply with Fs. Fs is the frequency emitted by the source. So Vs is the source velocity. Vs is more than 0 for a source moving in direction of wave. Same direction. Okay. Since denominator is less than 1, the observed frequency is always higher than the source frequency when the source is moving in the same direction as the wave. So just now, for example, ambulance is moving to the right. You also move to the right. Okay. So they are moving in the same direction. Another one is Vs is less than 0 for a source moving away from the observer. So for example, you observer is waiting at the bus stop. And then there is a moving ambulance. Ambulance will move away from you because pass by only. You stay still. Okay, so observed frequency is less than the source frequency. So to use the formula, you must understand where is the source and where is the observer. Where is the person who hear the source. Okay. Moving observer. FO equal to 1 per VO per V times Fs. FO is observed frequency. Fs is frequency emitted by source. And VO is observer's velocity. Vs is source velocity. And V is speed of sound. So here there is a boat, right? Police boat. Police boat give sirens, give sound. So this is the source. And then there are people who are at the land moving moving away from the source. So VO more than 0 for observer moving in direction of wave away from south. So this is direction of wave going there to the right. And then the observed frequency is always higher than the source frequency if VO or observer velocity is less than 0. Okay. So if the person who hear the sound is moving or running, then you must observe, okay, where is the direction. Okay, so for the formula just now, it can be summarized as Doppler effect formula, FO equal to 1 minus VO per V per 1 minus Vs per V times with Fs, where VO is the observer velocity. So the person, normally the person velocity how much? Running or walking, okay? And then V is the speed of sound. Okay. Vs is the source velocity, the boat speed. Okay, the boat speed, that is the source velocity. So you must differentiate between source and observer. Later don't know which one, you go and substitute wrongly. Okay. After that, note that the Vs and Vo to be positive when they move in the direction of wave propagation and negative when they are opposite to the direction of wave. So in the picture just now, the wave is going away from the boat. Okay. So we look at this example. A train approaches a platform at a speed of 10 meter per second. Okay. While it blows its whistle. Why need to blow the whistle? Because scared if there is someone nearby to the train track, later die. So before approaching the platform, already have a whistle to give some alertness. A musician with perfect pitch standing on the platform hears the whistle as middle C, a frequency of 261 Hz. Okay. So what this means, the middle C? Not sure. Okay. So anyone have seen piano? Piano have many keys, right? Like 61. So C, D, E, F, G, A, B. After that, after the 7, repeat back another 7. Okay, another 7, then continue another 7. So the C repeat many times. Okay, but here mention middle C means the C which is in the middle. Okay, if you don't know what this means, this one middle C. There are lower C, higher C. Okay, so this one is what they hear, the pitch. So this means middle C is in the middle of the piano, if you don't know. Okay, if you move to the right of the piano, the notes will become more higher pitch. If you move to the left of the piano, it will go to the lower pitch. Okay, more bass, more bass. Okay, if to the right, more soprano. A frequency of 261 Hz. There is no wind and the temperature is 0 degrees Celsius. What is the observed frequency of the whistle when the train is at rest? Okay. So for a moving source, the source Fs and observed Fo frequency related by V equal to 331 meter per second. This one is fixed value. Okay. V equal to 331 meter per second is fixed. Okay, don't ask me later 331 from where? That is the speed of sound in air at 0 degrees Celsius. Can it be more than 0? Can depend on the environment. Okay. Okay, so Vs is equal to 10 meter per second in the question given. Vs is V source, velocity of the source. Okay. So this one is the train. Train is the source who give the music. Train is the source who give the sound. So train is Vs, 10 meter second. Next is frequency of the observer is 261 Hz. Okay. So there are two different things, S and O. O observer, which is the people. S is the source. Okay, whether from train, from ambulance, or from boat. Okay. After that, substitute into this formula. They ask you, what is the observed frequency? Fs. Okay. Formula original like this. Okay, original like this. Then you want the Fs only. So this multiply with this, right? Cross multiply. This one bring left. So 1 minus Vs per V times with Fo. Become Fs. What happened to the 1? No need to write. 1 times Fs is Fs. Okay. Then substitute the value. Vs is 10, V is 331 times 261 Hz. So you get 253 Hz. Okay. So understand or not the calculation? Calculation easy only, right? Because substitute only, right? Okay.
Doppler effect.
Okay, wait ah. Shh.
And its applications. Have you ever heard a police car, ambulance, or fire engine pass and heard the siren change suddenly? Based on many observations, an Australian physicist and mathematician, J.C. Doppler, proposed the Doppler effect in 1842. According to him, the Doppler effect is the shift in frequency and wavelength of waves which emitted from a source moving with respect to the medium, a receiver moving respect to the medium, or even a moving medium. In this image, we have a ball. Let's pretend it's a fire engine. The fire engine is about to start sounding its siren in a minute. We can see the sound propagating towards from the source. This is the sound wave created by the siren. As you can see it travel on any side of the fire engine would hear the exact same sound because the wavelength and frequency is the same in all directions as the sound waves are coming from a stationary source. The wavelength is the distance from the crest of one wave to the crest of the next. It can also be true to true. The frequency of a wave is the amount of waves that pass a given point in 1 second. In the case of this video, it is about one wave every 2 seconds. In order to understand the Doppler effect, let's see how wavelength, frequency and pitch are related. We already know that the frequency of the waves in this video are about 1 every 2 seconds. But watch what happens to the wavelength when the frequency of the waves is increased to 4 every 2 seconds. Speed the siren up by 2. So, if you double the frequency of a wave, you halve its wavelength. Next up is the relationship between frequency and pitch. It's quite simple. All it says is that the higher the frequency of a wave, the higher the pitch will be. High frequency is equal to high pitch and low frequency is equal to low pitch. So, the relationship between all three is high frequency equals short wavelength equals high pitch. Low frequency equals long wavelength equals low pitch. Now, we can understand the Doppler effect. The Doppler effect explains what happens when the object that is creating the sound begins to move. This time, we will watch the sound waves with the siren muted. As you can see, the sound waves are bouncing up towards the front of the moving object. They are also growing further apart at the back of the moving object. This means there is an apparent change in the frequency and wavelength of the waves at the front of the object. There is also an apparent lowering of the frequency and wavelength of the waves at the back of the object. The object is still producing the same amount of sound waves, but its motion is making the frequencies and wavelengths to change at the front and back of the object. So, what would this change in frequency do to the sound heard at the front and back of the object? As we already know, the higher the frequency, the shorter the wavelength, and the higher the pitch. And the longer the frequency, the longer the wavelength, and the lower the pitch. Examples of Doppler effect. Now, let's see an example for the application of the Doppler effect. Consider an ambulance speeding past to you. The pitch of the siren increases as the ambulance approaches you, and the pitch decreases when the ambulance moves away from you. There is a similar apparent change in the pitch of the sound heard when the source of the sound is addressed and the listener moves towards or away from the source. The change in pitch is due to a shift in the frequency of the sound waves. Doppler effect is observed in light also. Suppose a star
Okay.
resists.
So we are concentrating on the Doppler effect in the sound, not in the light. So what you observe from the video just now? The second video is about the wavelength. Okay, wavelength. As the ambulance move, wavelength also move. Wavelength also change. Okay, between high pitch. High pitch just now they mentioned what? High pitch equal to high frequency, right? Who have high pitch in this class for singing? Anyone know your friend who have a high pitch in singing? So high pitch can sing higher notes. Okay, higher notes. So for example, in a choir, who know what is choir? Choir normally they have 3 different divisions: soprano, bass, and also middle. I'm not sure what's the name. Tenor, I think. Who know? Who have joined choir in school? Alto. Okay, if auto lah. But you know, for choir, they are separated into different pitch. Okay. So soprano, the one with higher pitch, one side. Bass, one side. So maybe soprano on the right, bass on the left. They are standing. So normally in a choir, you can have like 20 people to join together to sing. Okay. The one in the middle is the one which tenor for male. Okay. Tenor is correct. Alto for lower female. Okay. So you fall into which category? So nothing wrong if you fall into any category because you can cooperate with other people to have a nice sound. Okay. If the sound is only soprano also not so lively, you must have bass and middle. So normally in school, teacher will select. They have a test. Okay, they have a test to test you are falling in which category. So in school, teacher will test. If your voice is under soprano, you under soprano. So soprano will sing certain verse. Okay, bass also certain verse. And middle also. So middle is in between. Not so low and not so soprano, not so high. Okay, so this is a category in music or in singing. But since we learn sound wave, we also can apply that in the choir. Okay, wait, carry this. Okay. Next is echolocation. Sound wave can be sent out from a transmitter or some sort. They will reflect off any object they encounter and can be received back at their source. Okay. So, for example, for those who likes to practice singing, they will, because they will go into bathroom to sing, because it will have this echolocation. Your sound will be better. Something like that, okay? How about in the cave? In the cave have or not echolocation? Not sure. In the movies, if you go to cinema, what happen? You have this echolocation or don't have? Not sure also. No. No. Because the wall is covered with a soundproof, right? If not, next door you have another movie in the cinema. So can hear another movie. Cinema room. Okay. So in cinema room, you cannot hear another movie which is watched by other people in another room, because the surrounding of the wall. Okay, wall is fixed with soundproof. Okay. Maybe your house, if you are rich, you also have a small cinema at your house where your cousin can come, your other family members, aunties, uncle come to your house and watch cinema in your house. Okay. So other than cinema, mostly families gather in singing karaoke, right? So make sure it is not disturbing the neighbors. Okay. So if rich, not so expensive also, I think can do the soundproof. Okay. So bats can sense the Doppler shift between emitted and reflected wave. Other than that, ultrasonic imaging uses sound wave to view fetus. To view fetus, use ultrasound, we call it. Okay, another one is sonar. Sound navigation and ranging device sends ultrasonic pulses to find the depth of water below a ship. Why need to know the depth of water? Maybe there are treasure underneath. Want to check whether got flight drown into the sea? So use sonar to check whether got extra object or not. Okay. So summary of the topic. Sound is longitudinal wave. Speed of sound depends on material properties such as stiffness, density, and temperature. Sound intensity level depends on which level. Become more high intensity if you are near to the source of the sound, like ambulance or police. If you are near, you will hear louder, right? When louder, pitch is higher. So pitch higher, frequency higher also. If you don't want to hear very high pitch, you can move away from the sirens. Okay. Next is the echolocation and Doppler effect. So we have learned all this today. Any question? No question. Question on theories can be asked like, give an example of Doppler effect. Then you can give an example like ambulance moving towards the hospital, for example. Okay. So other application of Doppler effect are the sound of train whistle, the sonic boom, a related effect, the Doppler effect in light wave, and so on. Okay, so you can find out about the Doppler effect if you have time. Okay. Now we will take attendance.
Hi, Miss.
Yes.
Miss, for the assignment, right? When are we supposed to present?
2 weeks before final.
So week 12, is it?
Final is 3rd November, right? About there lah. When is the due date at the report?
20th.
There is someone who asked me to change it, so I said 25th, I think.
25th, Monday.
Is it lower? Yeah, I will change the setting for the assignment. Wait. Due date is 20th. So change to Monday, 25th. That is the latest that I can give.
Okay, Miss. And what about the
Hmm.
Um,
The
presentation.
presentation
Yeah.
should be 1 week before submission. So 20th can? 20th is Wednesday or the 20th, 20, 21, 22. 22 also can. Friday or our class during our class.
Okay, miss. I think
20th change to 25th. This one cannot change anymore, okay? 25th October, submission of report, assignment report. Any problem about the assignment?
no, miss.
Assignment report, submission date equal to
Excuse me, ma'am.
5th of, yes.
Excuse me, ma'am.
Yes, yes.
Ma'am, when you gonna explain the assignment?
Huh? When is? Hmm? Notice an error.
Can you hear me, ma'am?
Can. Your assignment is inside here. Under
No,
form.
but ma'am, but
Yes.
can you explain it on Friday to so that we can have a clear picture?
Oh, explain the assignment. Can. Friday, yeah?
Okay, ma'am. Thank you.
Excuse me, miss.
Assignment. Wait. Assignment presentation. We put one day only lah. Later, some present Saturday. Some present Wednesday. Assignment presentation. Can we have sample of presentation? Oh, can?
Excuse me, miss.
Ah,
Can you provide us like some topic to choose from? Like
topic
some
to choose
ideas
from.
or no, some ideas.
Pascal principle?
Pascal principle.
Anything related to fluid.
Okay, miss. Okay.
Assignment presentation is 20th, 21, 22. 22nd of October, okay? Because in the presentation, I can comment and you can prepare your report. Yes.
And miss, for the report, right? Is it a must to write 2,000 words?
No. Less than that.
Less than that. So what is the minimum, miss?
Minimum. About 10 page.
10 page.
Without the cover.
Okay, miss.
Okay.
Thank you.
But depends, you have many graph or picture. That's why we cannot specify the page. Because if you have, for example, I have one assignment for Industrial 4.0 subject. Even though it is 100 pages or 80 pages, but it's done by group, 4 students per group. So about 20 pages. Okay, 20 pages for each student is not much because they have a lot of graph to put inside there. So one graph with their explanation already 1 page. So if they have 4 graph, already 4 pages. But whatever graph or figure that you put in the report, you must have the explanation. Don't just put the figure, later no explanation at all. So figure 1 stated what. From the graph, what. Something like that, okay. Never mind, I will give the sample this Friday.
Okay, miss. Thank you.
Hi, miss.
Hi, Tom.
For the presentation, right? We have to record it or have to present it live through the Microsoft Teams.
Live first.
So we have to present it live, basically.
Yeah, the backup for your video is just backup in
Oh,
case, yeah,
okay. So
in case you sick or cannot come on the same day, I will not have another day for it. So you
also
submit
okay,
the
okay.
video in the same day. Yeah.
Also the video is just backup only.
Yeah, backup.
Okay.
But
Thank
there
you.
are some students who are shy to talk in front of people in class. Like girls lah normally. So they will record and send to me. But the date must be the same. If all present on the 22nd, the video also must be in on 22nd. You prefer to present or you prefer to have video, Tom?
Video, miss.
Prefer to have video ah?
Yes, it's
Then how to
easier.
ask?
Maybe after the video is done playing, you can ask us any questions after that.
Playing video during class, you mean?
Yes, miss.
Oh, during class. Serious ah?
Yeah. I mean, anything which is possible, lah, miss.
Because your class not many students can settle in one day. If like I have class with 71 student, but they also present in groups lah. So present about 15 minutes. All the 4 student must talk within 15 minutes. But your time, if you cannot finish in 10 minutes, you can finish in 5 minutes also. I think that assignment is not that long to do it.
Okay, miss.
So video you want to send first and then I open it during class.
I think that is fine, but I also want to get some opinions from others.
Oh.
Yeah.
Miss, so the video minimum 5 minutes, maximum 10 minutes.
Yeah.
Oh.
And miss, in the
Because
video,
sometimes a student present very fast because it's on water also, right? But then got time to ask question.
so miss, in these
Excuse me,
5
ma'am.
minutes, we should explain everything about the experiment that we did, yeah?
Yeah.
We should
No need
provide
the PowerPoint. PowerPoint no need.
no need
Only
the
you
PowerPoint.
show. Yeah, no need PowerPoint. Only you show what you are doing.
So if live presentation also like 5 minutes, 5 to 10 minutes or shorter.
5 minutes also can.
Okay.
Yeah, Sutesh?
Oh, nothing, miss, nothing.
Okay, I think we can see the video on the spot lah. Better, right?
Yes, miss. I mean, sometimes some of us will have some technical difficulties on the day, then it will waste time as well. Like Wi-Fi problem and all, yeah. And you know, it's
Okay, to open your face during presentation, can open your face at the beginning, then you can close.
okay, miss.
Because video must show it is really you, not somebody else is making it.
Okay, miss. Yeah.
One absent.
Oh wait, miss, I haven't.
Oh, I haven't
signed.
scan. Okay. If cannot scan, tell me now. We no girls. Okay. So video is just backup. Your class not so many. If many student, then need to send video. No time to see. But later, lecturer need to spend the time to see the video during other time than class. So problem for
Excuse
us.
me, ma'am. Ma'am,
Yes,
we have to record. We have to record our video. Then we have to play in front of class, or we have to present live.
Present live better. The record is done during the class. I can record. Okay.
So,
But if you
okay,
want to record, you save one place. Because there are cases where students are sick and then They send the file only for playing in the class. So backup is important. Because you must use the equipment, right? Later the equipment got problem or what, later you don't record. During the day, the thing don't work. Then you can open the video at that time. If all working, then okay. Okay or not? Or
Ma'am, we have to explain each and everything. We have to share a screen also that the thing we have done a word also. So we have to explain each and thing one by one.
no, explain the concept only. Okay, for
Okay.
example, Pascal principle. So you need to know the area how much. Where is the area that you count? You just show only there.
That means I can do buoyant also, right?
Can you do buoyant force?
Yeah.
Can. There are students who use the what you call that? The jack. The jack for the car to go up. That one also can. He used the real car. Record for
Excuse me,
backup
miss.
at the day have to present live. Yes. Yes.
Miss, like, can you like give me like some easy topic to do it, like some easy experiment to work on? Because miss, I search on many on Google's and in YouTube's. I didn't find some like an experiment to work on.
Need to research more. You type Pascal principle experiment. Got something will come out.
Okay,
Never
miss.
mind. This Friday I will show some sample. At the moment you find yourself first. Okay, I will show other sample from other class that have sent to me.
Okay, yeah, sure, miss. Okay, miss. Can I leave now? Because like I
Okay,
have
can.
things to do. Okay, thank you,
Okay,
miss.
thank you
Have a nice
all.
day.
Have a nice day.